Download this code from codegive.com, link in the description below. Detailed tutorial on address resolution in DNS domain name server with example using want2host. This tutorial will delve into the intricacies of address resolution within the domain name system, DNS, particularly focusing on the hypothetical DNS provider want2host. We'll cover the fundamentals of DNS, the different types of DNS records, the resolution process itself, and finally, how to manage DNS records using want2host with illustrative code examples, assuming want2host provides a command line interface or API. Introduction to DNS, the Internet's phonebook. The domain name system, DNS, is a hierarchical and distributed naming system for computers, services, or any resource connected to the Internet or a private network. Think of it as the Internet's phonebook. Instead of remembering IP addresses, like 192.168.1.10, we use human-readable domain names, like google.com. DNS translates these domain names into the corresponding IP addresses that computers understand. Why is DNS important? Usability. It makes the Internet easier to use. Remembering www.example.com is far easier than memorizing 203.0.113.45. Scalability. The distributed nature of DNS allows it to handle the enormous amount of name resolution requests on the Internet. No single server holds all the DNS records. Flexibility. DNS allows for services to be migrated to new IP addresses without users needing to update anything. For example, a website can move servers and have its DNS record updated without users even noticing. Redundancy. DNS is designed with redundancy in mind. Multiple DNS servers are used for each domain, ensuring that if one server fails, others can continue to provide name resolution. 2. DNS hierarchy and components. DNS follows a hierarchical structure, resembling an upside-down tree. 1. Root servers. At the very top of the hierarchy are the root servers, represented by a single dot. There are 13 logical root servers worldwide, managed by different organizations. They know the location of all the top-level domain, TLD, servers. 2. Top-level domains, TLDs. TLDs are the highest-level domain names, such as .com, .org, .net, .edu, .gov, and country code TLDs, CCTLDS, like .uk, .ca, .de. TLD servers are responsible for authoritative information about domains registered under that TLD. For example, the .com TLD server knows the authoritative name servers, for example .com. 3. Second-level domains, SLDs. SLDs are the domain names registered beneath TLDs, such as example in example.com. The domain registrar assigns the management of these domains to the domain owner. 4. Subdomains. Domains can have subdomains, which are further divisions of the main domain, such as www in www.example.com or blog in blog.example.com. Key components of DNS*. Domain name. The human-readable name used to identify a resource on the Internet, example www.example.com. IP address. The numerical address assigned to a device on a network, example 192.168.1.1. DNS resolver. Recursive resolver, a server that performs recursive queries to find the IP address corresponding to a domain name. Your ISP typically provides a DNS resolver, or you can use public DNS resolvers like Google's 8.8.8.8 and 8.8.4.4, or Cloudflare's 1.1.1.1 Asterisk authoritative name server asterisk a server that holds the definitive DNS records for a specific domain. These are the servers configured in the domain registrar's control panel. Asterisk DNS records asterisk entries stored in DNS servers that map domain names to IP addresses or other resources. 3. DNS record types. DNS records are the heart of the DNS system. They contain information about how to translate domain names into IP addresses and other resource information. Here are some of the most common DNS record types. Asterisk A, address, record asterisk maps a host name to an IPv4 address. Example www.example.com-203.0.113.45. Asterisk AAAA, quad A, record asterisk maps a host name to an IPv6 address. Example www.example.com-2001db81. Asterisk name, canonical name, record asterisk creates an alias for a host name. Useful for redirecting one host name to another. Example blog.example.com-example.com. Asterisk MX, mail exchange, record asterisk specifies the mail server responsible for accepting email messages for a domain. It also includes a priority value, lower value means higher priority. Asterisk NS, name server, record asterisk delegates a domain or subdomain to a specific authoritative name server. Asterisk text record asterisk allows administrators to store arbitrary text information associated with a domain or host name. Used for various purposes, including domain ownership verification and SPF/DKIM records for email authentication. Asterisk SRV, service record locates services within a domain, specifying the protocol, port number, and target host name for a service. Asterisk PTR, pointer, record asterisk maps an IP address to a host name, reverse DNS lookup. Used primarily for email reputation and spam prevention. 4. The address resolution process, simplified. Here's a simplified overview of how address resolution works. One user initiates request asterisk a user enters a domain name, example www.example.com, into their web browser. 2. Local resolver query asterisk the user's computer sends a query to its configured DNS resolver, usually provided by the ISP. 3. Recursive query asterisk the DNS resolver initiates a recursive query process. Asterisk root server query asterisk the resolver first queries one of the root servers. The root server doesn't know the answer directly but provides the address of the authoritative name server for the .com TLD. Asterisk TLD server query asterisk the resolver queries the .com TLD server. The TLD server doesn't know the answer directly either but provides the address of the authoritative name server for example.com. Asterisk authoritative name server query asterisk the resolver queries the authoritative name server for example.com. This server does have the answer, the A record for www.example.com. 4. Response received asterisk the authoritative name server returns the IP address to the resolver. 5. Caching asterisk the resolver caches the IP address for a specific time to live, TTL, to speed up future requests for the same domain. 6. IP address returned asterisk the resolver returns the IP address to the user's computer. 7. Connection established asterisk the user's computer uses the IP address to connect to the web server hosting www.example.com. V. Managing DNS records with want2host, hypothetical example. Let's assume want2host offers a command line interface, CLI, or a REST API for managing DNS records. The exact syntax and commands will vary depending on the actual implementation. We'll illustrate with some example commands. Assumptions asterisk. Asterisk want2host is the CLI tool. Asterisk you're authenticated with want2host using API keys or credentials, example stored in environment variables. Asterisk example.com is your domain registered with want2host. 1. Authentication, example, environment variables. 2. Listing DNS records asterisk asterisk. This command might output a list of records similar to this. 3. Adding a DNS record asterisk asterisk. Let's add in a record for api.example.com pointing to the IP address 203.0.113.15. Asterisk example.com, the domain to modify. Asterisk API, the host name, subdomain. Asterisk A, the record type. Asterisk 203.0.113.15, the IP address. Asterisk 3600, the TTL, time to live, in seconds, 1 hour. 4. Adding an MX record asterisk asterisk. Let's add an MX record to handle email for the domain example.com. Asterisk at, represents the root domain, example.com. Asterisk MX, the record type. Asterisk mail.example.com, the mail server. Asterisk 10800, the TTL, 3 hours. Asterisk priority equals 5, the priority value. Lower values are preferred. 5. Adding a text record, for SPF. Let's add a text record for SPF, Sender Policy Framework, to help prevent email spoofing. Asterisk V equals SPF1 MX include underscore SPF.example.com all, the SPF record content. 6. Modifying a DNS record asterisk asterisk. Let's change the IP address of the www record. 7. Deleting a DNS record asterisk asterisk. Let's delete the blog name record. 8. Example using a REST API, Python. This Python code provides a basic example of interacting with the want2host API. It includes functions to list DNS records and add new records. Remember to replace your _API_ key and your _API_ secret with your actual API credentials. Also, the specific API endpoints and data formats may differ depending on the actual want2host API. Error handling and more comprehensive CRUD operations, update and delete, would be added in a real-world implementation. 6. Important considerations and best practices. Asterisk TTL, time to live. The TTL value determines how long resolvers cache DNS records. Lower TTLs allow for faster propagation of changes but can increase the load on authoritative name servers. Higher TTLs reduce the load but can delay propagation. Choose a TTL that balances these factors. For records that rarely change, example NS records, a longer TTL is appropriate. For records that might change more frequently, example A records during a migration, a shorter TTL is preferable. Asterisk propagation asterisk DNS changes don't happen instantly. It takes time for changes to propagate across the internet as resolvers refresh their caches. This propagation time can vary, but it typically takes up to 48 hours for changes to fully propagate. Asterisk DNS security asterisk DNSSEC, Domain Name System Security Extensions, is a suite of protocols that add security to the DNS by digitally signing DNS data to ensure its authenticity. Consider enabling DNSSEC for your domain to protect against DNS spoofing and cache poisoning attacks. DNS monitoring. Monitor your DNS records to ensure they are configured correctly and that your domain is resolving properly. There are many tools available for DNS monitoring, both free and paid. Tools like Dig and NSLookup are useful for basic DNS troubleshooting. Redundancy. Use multiple authoritative name servers for your domain to provide redundancy and ensure that your domain remains resolvable even if one server fails. Want2host, like most reputable DNS providers, should provide multiple name servers. Zone files. DNS data is often stored in zone files, which are text files that contain the DNS records for a domain. Familiarize yourself with the format of zone files, although you'll typically manage DNS records through a GUI or API provided by your DNS hosting provider. Testing. After making any DNS changes, test them thoroughly to ensure they are working as expected. Use online DNS lookup tools to verify that your domain is resolving correctly from different locations. Reverse DNS. PTR records. Configure reverse DNS records for your IP addresses, especially if you're running a mail server. Proper reverse DNS can help improve email deliverability. Dynamic DNS, DDNS. If your IP address changes frequently, example with a home internet connection, use a dynamic DNS service to automatically update your DNS records whenever your IP address changes. By understanding the principles of DNS and utilizing the tools provided by services like want2host, you can effectively manage your domain's address resolution and ensure that your online presence remains accessible and reliable. Remember that this is a simplified explanation, and the specific features and functionality of want2host might differ. Refer to the official want2host documentation for complete information.